Assalamualaikum. Hai, jumpa lagi. Selamat petang semua. Today we will do revision for chapter 1 AC circuits. So this chapter 1 introduction to AC circuits comprise of introduction to AC, characteristic of sinusoidal function, phasor representation of sinusoid, impedance and admittance, parallel and series combinations in the frequency domain, and Ohm's law, Ohm's and Kirchhoff law in frequency domain. Okay, next. So this is basically sine wave, the normal sine wave that we always find in electrical engineering. So this is voltage and this is time. Okay, so we have few parameters. T, the T is like this from peak to peak, and we have Vm, maximum voltage, pi, 2 pi, and so on, and this is omega T. So what are those parameters meaning? Vm here is the maximum value of the voltage, or we call it amplitude. Okay, so Vm normally Vmax we call it. T is the time taken or period, time taken to complete one cycle in seconds. F is the frequency or the number of cycle per seconds in unit hertz. Omega is angular frequency in unit radian per second, and pi or phi is the phase angle of the sinusoid function. The unit of phi is in degree or radian. So this is few equation, normal equation, common equation for sine wave. So pi radian is equal to 180 degree. F equal to 1 over T, or T equal to 1 over F, vice versa. F in unit frequency, in unit hertz, sorry. Omega is 2 pi F in unit radian per second, and VRMS is Vmax over Z2. RMS means root mean square. So this is the sine wave, which represent the AC current or voltage. So if we have voltage, we have V. So this is the sine wave. Sine wave or sinusoidal voltage supplies a voltage that varies with time, a time varying voltage signal, sine wave. So this is the general equation or expression for sine wave, which is V equal to Vm cos omega t plus phi. Phi, what is phi? Phi is phase angle. So Vm is V max cos omega t plus phi. So let's assume we have two sine wave. Okay, let's examine two sinusoids or sine wave. We call it V1 and V2. So V1 equal to Vm sine omega t without the value of phi, without the value of phase angle, or we call it phase angle equal to 0. And V2 equal to Vm sine omega t plus phi with some value of phi. So we can see here there are two signal. V1, this one, V1 equal to Vm sine omega t plus phi equal to 0. So phi equal to 0 meaning it starts at t equal to 0. And V2 equal to Vm sine omega t plus phi. Phi is the value of this one.
Yeah.
Okay. Okay, so from this you can see V2 leads V1 or V1 lags V2. Next example. Okay, example 1, simple example. For the following sine voltage, find the value V at t equal to 0 and t equal to 0.5. So V equal to 6 cos 100t plus 60 degree. So just replace the value of t into the equation, we will get the answer. So be careful when adding omega t and phi. The unit of omega t is radian. The unit of phi is degrees. Okay, to add those values, both we need to convert both omega t and phi into the same units, either into phi or into radian units. Okay, so this is the relationship between radian and degree. So if we want to convert radian into degree, we multiply by 180 over pi, and if vice versa, we need to convert from degree to radian, multiply by pi over 180. So example 2, a sine wave is given by expression V equal to 300 cos 120 pi t plus 30 degree. Okay, what is the frequency in hertz? So what is the frequency? This part, convert this part into hertz. What is the period? Millisecond. What is the value of V when t equal to 2.778 millisecond? Just replace this value into equation. And what is the RMS value of V? So RMS value is Vm over Z2. Okay, that's all. Thank you very much.